Okay. Can you hear me? Okay. Okay. Can you hear me? Is it on? Has it started yet?
No.
It says it's
Maybe that's in the lane.
Hmm?
Should I call
Yeah. Okay. Yeah. I don't know why it's not working. It worked earlier.
Oh, not this week.
Oh. You can see the right after the start. Okay.
Oh, that's
Okay.
It is not.
Okay. So,
Is it good about
okay. Yeah. All right. Hi, everyone, and welcome to this first coding session of 6.00.1x. Hopefully, this will help you see the general thought process of writing a program given a set of specifications. So I'm Anna Bell, and I've been the course lead for this course for the last couple of iterations. So before we begin, I should preface these coding sessions by saying that people learn in different ways, and writing programs is really no exception to that. So I know many of you tend to jump right into writing code, and I admit that I also may do that sometimes, but it's really often best to start out by reading the problem a couple of times and by making a small drawing or maybe an outline of how you would approach it. Also, maybe writing out some sample inputs and outputs to get you thinking about possible test cases you'll have to worry about as you're writing the program. That's also pretty useful. So, sorry if we are having technical difficulties. But hopefully you can still hear me. Yes.
This is
Echoing. Okay. If it's echoing, I'm not sure what to do about that. I'll try talking closer to the screen, and I'll start actually screen sharing right now. Okay. Okay. All right. So our task, as I posted on the course website, is to Extract an email address from a string given by a user. So I'm first going to just begin by typing out or copy and pasting, in this case, these specifications into my editor. So I use Canopy, as you can see, and I'm just going to paste this. One second. I've just pasted the specifications for this program just to remind myself. So given a string, extract the email address from the string. If there is no email address, then print an appropriate error message. Other specifications to keep in mind were that we are going to assume that what the user inputs will contain no more than one address, so it could contain no valid email addresses. We won't allow the user to, or we'll assume that the user won't input any special characters other than the ampersand and the dot. The email address will be denoted between spaces, so we're going to have sample inputs like a bunch of some words, space, some more words, space, maybe a word with an @ sign, space, maybe an email address, space, another set of letters. So we can see from the example down here, there is one valid email address in this example, and this is hopefully the one that we're going to extract with our program. Okay, so now that I've typed out the specifications, the first thing that I do is I'm going to switch over to a pen and paper, or in this case, I'm just going to use Paint so that you guys can see the sort of things that I would be, let's see. Screen, Paint. Okay, so here is my pen and paper. And one thing that I would that I first start out doing is I think about the inputs and outputs that my program will take in and spit out. So I can have inputs that have spaces in them, which is a slightly more complicated case. Or I can have inputs which have no spaces in them. So I'm going to first think about this easier case where the user just inputs a string that doesn't have any spaces in it. So this is going to be an easier task for me to think about because I don't have to think about finding out where exactly the email address is in this long string that may include spaces. So without thinking about spaces in the input string, the only thing I have to worry about is whether or not I have a valid email address. So the format of an email address will be something like, and I'm going to write this down now, maybe some text at other text dot more text. And some characteristics of this string are that it has both an @ and a dot. The @ comes before the dot. The @ and the dot are not next to each other. We will never have multiple dots in a valid email address, so no multiple dots. A valid email address does not start with N, and a valid email address does not end with a dot. That's a dot. So these are just some general rules that I've thought about that makes a valid email address. So as I'm writing my code, I think of these as little if statements. And if any of these are true, then that means that the text is not a valid email address. Okay, so I'm going to zoom out a little bit. So this is the simple case when we have no spaces in the string. Now, with spaces, we actually would have to repeatedly look at the text in between every pair of consecutive spaces and ask whether the text is an address or not. So let me draw out this case. So I'm going to zoom in and go right. So in this case, I might have text that's, ABC, a space, B at D, another space, F, G at H dot I, another space, M, N, O, or something like that. So this is something a little bit more complicated that the user might enter. And notice that we do see that there's a valid address in this long string that the user entered, but there's also these spaces which actually complicate things a little bit. So if we just think about our algorithm, what we're going to do is we're going to start by finding consecutive pairs of spaces. So we're going to start looking at the beginning of the string, and then we're going to find the next place where we have a space. And we're going to keep track of this maybe like as a start and maybe an end. Indices. And we're going to look at the string that exists in between these two indices. In this case, it's ABC. And we're going to ask, is this a valid email address? And how do we go about determining whether this is a valid email address? Well, we already wrote a kind of procedure for doing that. So it's basically looking at these rules here that we've thought about before for the simple case of just having a string that may or may not be an email address. And we can just call this procedure on our first string here, ABC, and ask if it's a valid email address. And hopefully it should return no, which means that in our algorithm, we would look at the next consecutive pair of spaces. So we would start looking at beginning from here and ending here. And we're going to ask, is B at D a valid email address? And hopefully it should also return no. Then we're going to keep looking at the next pair of spaces. So we'd start from here, and then we'd go until here. And we're going to ask, is FG at HI? H.I a valid email address? And the answer should hopefully be yes. And that's when our algorithm would stop and would return this valid email address. If there was no valid email address, we would continue on going, and we would reach the end of the string that the user inputted here, and we would just say, we've reached the end of the string. We haven't found any valid email address, so there's no valid email address in this string. So that's our general procedure for finding a valid email address within this long string that includes these spaces. There. So notice that for every string within this, in between pairs of spaces, we're actually calling the same procedure, which is this one here. We're asking the same set of questions to determine whether or not it's an valid email address. So that means that we can actually save a little bit of hassle and make this procedure into a separate function that we'll just call repeatedly. Okay, so now that we have this in our minds, we can go ahead and switch back to Canopy, and we'll do that. Okay, and inside Canopy, the first thing I'm going to do is write this function. So to write a function, as usual, we start with def, and then we're going to give it a name. So in this case, it should be something that it would help you recognize what the function does in the future. So we're going to call it is valid address. That seems like a reasonable name. And it's going to take some parameter, which is just some string. And is valid email address and some string are just names that I have picked to help me identify what's going on here. And you can pick whatever names you'd like. Don't forget the colon at the end of the definition. And now we can write the body of the function. So what did this function do? Well, it's going to basically go through these if statements, and it's going to return false if any one of these is true, and otherwise it's going to return true. So a lot of these statements have something to do with is there an ampersand sign and is there a dot. So I'm going to just do a Google search or look at the Python documentation for some sort of function that already exists on strings to find whether or not a character exists in a string. And I don't just want to find whether or not it exists. I want to find the exact position. Because if you remember, we have a couple of these rules that say if the ampersand is before the dot, then it's valid, otherwise it's not. So we're actually interested in looking at the position also of these specific characters, the ampersand and the dot. So I can open up Google and just do a general search, and I can even screenshot this. Just a sec. So I can screenshot my search. So I would just search for something like Python, character in string, something like that. And I can look at the official Python docs, or I can just look at the first thing from Stack Overflow. So it seems like there's an answer here which says you can use the in operator, which we've seen before, but this only tells me whether or not it's in it. It doesn't actually tell me the position. This find looks promising. So then I can go to the official Python documentation and do a search for find, and it says, you can call it string.find, and it returns the lowest index in the string where the substring is found. And it returns -1 on a failure. So if the character I'm looking for is in the ampersand sign, if it's not found in the string, then it'll return a -1. And if it is found in the string, it's going to return the index where it's found. Okay. So let's go back to Canopy. So I can use this find function. So let's first create some variables that hold the position. So we can say pose of the ampersand, position of ampersand equals my sum string dot find, and I want to find the ampersand sign. And then I can do the same thing with the dot equals sum string dot find dot. Okay, so now the variable pose at and pose dot hold the indices of where the ampersand and the dot are. So I can just go through the rules that I wrote in, on my paper or in Paint, and I'm just going to start going through each one of them and convert them into code. So the first thing I had was if there's no ampersand or there's no dot, then that means that there's no valid email address. So if pose at equal -1, that means it's not found, or pose dot equal -1, that also means the dot isn't found, then we will just instantly return false. Notice that I'm using the keyword return because this is a function and the user is going to want the return value back. I don't just want to print it to the screen. I actually want to give this value back to the user. Okay, now if we've passed this test, then we can go on to the next test. We can say if pose at is greater than pose dot. So if the ampersand sign is later than the dot sign, then it's not really a valid email address. So again, we'll return false. The other case is if some string dot, well, let's do this. Let's think about these other, what were the other cases? At before dot, the at and the dot are not next to each other. So that would be if pose at minus pose dot equal 1, but actually the ampersand, we could have ampersand dot or dot ampersand. So I'm actually going to take the absolute value of this, which means that this checks for the case when it's ampersand dot or dot ampersand also. Then we can return false. Let's see what the other cases were. We don't want to have multiple dots, so again, I can just look up on Google how to find whether Python string contains multiple characters, and there's actually a function called count that you can call in the string. So we can say if some string dot count dot is greater than 1. So if there's more than one dot in our string, then it's not a valid email address. We can just assume that. Then we can return false. And we can also do this for at as well, the ampersand as well. And the last couple of cases were an email address can't start with an ampersand and it can't end with a dot. So those should just be something like if pose at equals 0. So that that means that the index of the first instance of the at was the first character in the string. Or That is true. So I think someone just said a question. You can have multiple dots, that's true. But for simplicity, we can just assume that we'll just have a simple email address that just has one dot. I mean, yeah. So, yeah, just for the sake of simplicity, we'll just assume that. But that's true, you can have more than one dot in an email address. So we were checking if pos at equals 0 or pos dot equal to, so the last character in the string is actually just the length of some string minus 1. Then we return false. And so if any of these are, we can actually also set these as else-ifs. But in the end, if we haven't gone through any of these, then we would just return true. Because if none of these conditions hold, then in our eyes it is a valid email address, so then we would just return true. Okay, so we've written this short function which just checks whether one email address is valid. And what you want to do is you want to just, as you're writing your programs, you don't want to write the whole program and then test it, because you're going to get errors which might be from something that you wrote very early on. So what I'm going to do right now is just quickly test whether what I wrote is correct. So to do that, I can just call the function is valid address, and I'm just going to give it some string, so ABC, and I'm going to print whatever gets returned from this function. So I'm just going to say print is valid ABC, and if I run it up here, then ABC is not a valid email address, so I should get false. So I can just go ahead and quickly check each of these cases. So this should actually return true. If I have the at right beside the dot, it should return false. If I have dot ending in the dot, it should return false. If I have an at the beginning and maybe some other text at the end, it should return false as well. If I have valid email address but the at and the dot are backwards, it should return false as well. So it seems like this function is working fairly well, just as we expected. Okay, so now notice we've written this bunch of code here in this function, so now we can just call this function on these short pieces of string inside our larger program. So I can just delete this test here. So now we can start writing the actual program. Actually, I can even write a comment here that says something like, checks whether string is a valid email address. And so now we want to write our whole program. So the first thing that we'd want to do is get user input. And for this, we're going to use raw input, as we have done in the past. So I'm going to call it user input equals raw input. And we're going to ask something like, please enter a string. And so this is just going to ask the user for a string. And then what I can do is I can write the part of the program which doesn't actually include spaces now. So it's just the part of the program where we assume that the user would just enter something without spaces, or maybe with spaces at the beginning or at the end. So just no complicated input where you have text, space, text, nothing like that. So let's go ahead and write that. So what we can do is we can even have, for example, I would think of it like I can have a more simpler check which says if at is not in user input, then if there's no ampersand in the user input at all, then that means that there's no valid address to begin with. So we can just take care of that case right away. So we would just print something like no valid email address found. So we can do that. And then elif else if there's no spaces in the user input, then we can just do our check right away. So we can say if is valid email address, and we're going to give it here our user input. Then if it's a valid email address, then we would just print address is, and then user input. And otherwise, we would print what we printed up there, which is no valid email address found. And I can already notice I made a mistake, so is valid email address is not actually the name of the function. I think it's just is valid address. Yes, that's right. So we can try to run this, and just to check that we're getting user input correctly. So I ran it, and it says please enter a string. So I can say a at a.a. And it should hopefully find the correct address, and it does. Now, one thing I'm thinking about right now is I can take care of the case where the user inputs maybe spaces at the beginning, so they could have space, 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 a at a.a, for example. So right now, my program doesn't really take this case into account, but I could theoretically take care of it right now. There is a function which removes spaces from the beginning and the end of a string. So if I look at my raw input and I say something like, the function itself is called strip, so I can call strip on my raw input. So this is what I'm calling the function strip on, and strip removes spaces from the beginning and the end. Then theoretically the user input should be just a at a.a if I had spaces. So if I run it again and I do space, 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 a at a.a, then yeah, theoretically it should have removed the spaces, and with space. Or maybe I don't need to. All right, we'll come back to that later. Okay. So So this takes care of, so don't worry about the case where we might have spaces at the beginning, at the end. So this takes care of the case where the user doesn't input anything with spaces. So that's the if and the elif. Now, in the else, this is going to be, and we can even comment that out, case where user enters string with spaces. Okay. So in this case, I'm thinking that, so we talked about having these two sort of pointers that find out where the first case, where the first space and the next consecutive space is. So I can use the find function for that as well. So I can say, I can call it start, as I did in my image. Start equals user input dot find, and what I want to find is a space. And end equals user input dot find, and I want to find another space. But the second space that I want to find, I want it to start. So by default, find begins looking at the start of the string, and it will return the first instance that it finds. So if I leave it like this, end, the value of end, the index of end will be the same as the index of start. So I actually want to start finding this space after I've already found my start. So if I look at the documentation for find, it says that it takes optional arguments it finds optional arguments where to start looking from. So I want to start looking from start, not from 0, because this one is essentially 0, like that. So once I start looking from start, then that means that my end will be the next consecutive value index of where the next space exists. So theoretically, everything between start and end should just be a string that is potentially an email address. So what I can do here is if is valid address, and here I would say user input start end. So this means that I'm calling this function is valid email is valid address on my substring, and this substring is everything in between the two spaces that I just found up here. So if that is a valid email address, then I want to print address is capitalize, and I print the actual address. So user input start to end. And since I've already found it, I'm done. I don't need to do anything else. So, but if I didn't find it, else I have to do something. So what do I need to do? So now I'm just thinking about what I need to do here. So I actually have to have a loop. And this loop is going to increase. So I can even start out with something like while true and indent that. And in this while true loop, blah, 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 I do some stuff. And if it's a valid address, I print that and I break. So already I can write that down. So yes, I think a loop makes sense to do in this case. So while true, I do this, I find this, the two spaces. I check if the stuff in between the spaces is an address. If it's true, I break. Otherwise, I have to do something. So what do I need to do? Well, it's going to have something to do with the start. So I actually want to start finding the next consecutive space based on some sort of other index. So I need to keep track of another index. So we can say something like @ equals 0. And this @ means where I'm currently at, and it's just another index like start and end. And this, and so let's see. If I start, currently it's 0, so I can actually do this, because @ is originally 0, and end is originally start, or we start looking after the start. If it's an address, if it's valid address, I do that. Else, so in this else, I need to do something with my @. So I need to increase my @ variable to start looking for the next consecutive space. So @ would equal to end, I think, and that should make sense. So if we do that. Let's try this out. Let's run it, and we can give it just, a regular string, and that should work. Good. And now let's give it a string with some spaces in it. A@a.a, bbb. So in this case, it should. So I hit an enter, and it's not actually doing anything, which means that I have an infinite loop. So I'm just going to exit out of the infinite loop. I just restarted the kernel. That's what you do in Canopy. So you just do run restart kernel when you get an infinite loop. So since it didn't really end, that means I have an infinite loop. So what I do here to start debugging, notice that we made a mistake. And to start debugging, I can start printing some of my variables out. So let's print here intermediately start and the value of start and say equals and so just to begin with, let's print our start and end variables inside our loop and see what happens. So a bbb. So notice that, and I'm going to restart the kernel, my start and end variables are the same. So that means I did something wrong with one of my find spaces here. So if I start this 0, so my end, I want to start looking from one past the start. Because I don't want to start looking at the space. I want to start looking at the next value past the space as the end. So that should hopefully work. Yes. So notice that in this case it did end. It found no valid email address because I wrote a.a. So I can run it again and say a@a.a, bbb. And indeed, You can see my debugging statements are still there. My start is 3, my end is 9, and it did find the address. So I guess that's a common mistake. Even I do it. You know, even advanced programmers do it. It's just you have to be careful with these indices, especially since they start from 0. Computer science. So in this case, the error was that I started I started looking for the next space at the space. So obviously, it would find it just there. Okay. Great. So the program is sort of working now. Now we mostly just have to tweak maybe some very specific cases. So let's see. Now let's look at let's see. Let's start inputting just some addresses just to test it out. So let's say our email address was at the start. So we know that it works if we have an email address in the middle of two strings that are not email addresses. Now let's see what happens if we have an email address that's at the start. So it looks like we've entered another infinite loop. So if the email address is at the start of the line, the start of the input, it seems like our program can't handle that. Okay. So we see that we end up flip-flopping between start is 5, end is 1, and start is -1, and end is 5. So now I have to think about how I could fix this. Okay. So I can add another case here in my else. So I can say something like start equals 0. So the problem is that we're finding our spaces and we're completely skipping over the case where we're completely skipping over the first string. Because when we do start equals user input dot find at, there's no beginning space. So we find the first space at an index that's greater than 0. So we actually have to take care of this just before the while loop. And we can just say start is equal to 0 and end is equal to user input dot find. And we can find the space as usual, start plus 1. Okay. And we're doing actually the same check again, is valid address, user input, start to end. That's right. So in this case, I'm just going to print the same thing I printed here, like that. So just to remind myself what I did here, I'm going to write a comment and say, take care of case when valid address is the first string before any spaces. So just to recap, inside our while loop, the start value gets the index of the first space. If our email address is at the beginning of the line, this start value will completely skip it, which is why we add this bit of code here, which has our start value to be 0, and our end, which is the next space, to be the index of the very first space. And we just do this extra check here if it's valid, if that first bit up until the first space is a valid email address, then we just print it. And do that, and else we do all this stuff here. So if the first bit isn't a valid email address, then we can keep going and we can keep looking at the other values, the other chunks of text in between the following spaces. Okay, so let's run this and let's test it with that case again, where we have an email address at the beginning, AABDPB, and voila, it actually works as intended now. And let's maybe just do another check that it correctly handles the rest of the cases. Oh, it doesn't. What happened? Okay, what did I run? A at a.a. Okay, that's correct. Okay, I must have entered something. So in this case, it does find, my previous cases do work correctly when an address is in the middle. Okay, now what if, the last case to check is what if an address is at the end of the user input string? So let's run this and say that, and then if the address is at the end, it enters an infinite loop. So let's stop it by restarting the kernel. And now we have to take care of this as well. So how can we fix this? Okay. So if a valid email address is at the end, what happens? All right, so I have to think about it. Let's try again. Just. Oh, I see. So it seems that the problem is actually this. Yeah. Okay. So notice. So I think there actually might be something wrong with my original, my is valid address check. And the problem is again a off by one error. So if I run it, if I ran it with, and I'm just going to type it in here as a comment, a at a.aa, that worked. That was correct. But if I did, that was incorrect. So I think, and we'll test this out, it thinks that there might be a dot at the end of, it might return that it's not a valid email address. Let's see. Yeah, I see. But now it cuts it off. So there's definitely an off by one error somewhere. Let's see. So first let's double check that is valid address is correct. So if we look at the case where we have a dot at the an ampersand at the 0th position is correct, or a dot at string minus. So if we have a dot at the last position, and the last position is -1, so that should be correct. And before we ask for user input, let's just quickly test that out again. Like that. Oh, I see. I'm just going to comment out the rest of the program. So that is correct. So that is false. And that should also give true. Yes, so that is correct like that. I see. So I guess someone says if the string doesn't have a trailing space, find fails if it's a last address. And you're probably right. Writing code under pressure. So that's correct. So if there definitely is an extra letter or a space, then the code does actually work. So it doesn't work when it is the last yeah, when there's no ending. So the way we can deal with that is, let's see here. That'll be a special case that we'll have to take care of, I think. Start user input. So if it hasn't found it yet, at is equal to end. And we don't find another at, which is why, let's also print our at. And let's run it with this case. That's an error there. It should be like that. So let's see. So again, we flip-flop. So start gets a value 3, end gets a value -1, and at gets a 3. And then we go into this else, and at becomes -1, because that's what end was, and we no longer find that, right? So maybe we can do something here that says if at equal to -1, then we can print that no valid email address found, and we can break. So break means get out of this while loop, and it would actually even end the program. So we can try that. So that means if end is ever -1, that means we've reached the end of our string and we haven't found a valid email address. So let's try that out. Yeah. So that now works. And we can run it again with previous values and see if that works. That works, yep. And we can try if the address is at the beginning, and that also works. So Right. So, so I think this is pretty much the program. So I can also write a small comment here that says case, take care of case when valid email not found and reached end of input string. And so now, so notice that I've sort of written comments as I've gone along in cases that I've found when I was debugging that I had to take care of specially. Yeah, so instead of taking care of the case where instead of taking care of this case where the valid email address was at the end, we could have also added an extra space at the end. I guess that's what some people are suggesting. In this case, we just took care of it by yet an extra check, which is also a reasonable way to deal with this problem. So yeah, so I was saying that as I've gone through this debugging process, I've done it intermittently, so I didn't just do it at the end, and I've taken care of cases as I found them, and then I also double-checked to make sure that things didn't get broken. And as I took care of cases, I wrote these comments here. So notice that the large chunks of comments are these special cases, which I found during my debugging, and which I found that were not just the usual, way of just writing the program. So it's this part where I had to take care of the special case where the email address was at the end, and the case where the email address was at the beginning. The rest was pretty straightforward, which was also in my general outline. So the general outline is something I could reproduce, but this debugging is the more time-consuming aspect of it. So now that I've finished writing the program and I've tested it sufficiently with multiple test cases and all these edge cases, I can go back and I can add more detailed comments just to sort of remind myself in the future where certain parts of my outline exist. So here I can even write something like, I remember the end, finding the end was a little tricky as well, so I could write myself a comment saying, start looking for the next space one index after the first space, or something like that. And here I can remove this debugging statement. I think the rest of the program is fairly straightforward. I can also comment here saying take care of simple case where can tell right away there is no email address. And yeah. So I think that's pretty much it. Let me make the font a little smaller, move down so we can see more of the program. So this is a good 60-line program, I guess, with some comments. Notice that we wrote this function, just to recap, notice that we wrote this function, which helped us a lot, actually. And we were able to write this function because we drew out some test cases earlier on a piece of paper and a pen, and because we drew our outline and thought about the problem for a little bit before we started writing code. So notice that if we didn't actually write this function, we would have to paste this entire code, whatever this is, maybe 10 lines of code, in multiple places. We would have had to paste it in here, and we would have had to paste it in here, and we would have had to paste it in here. So in 3 different places we would have had to paste it, and that could have gotten messy really quickly, especially while we were debugging. So I think it's good that we wrote a function to begin with, and we broke down our problem. And that's something to think about as you're writing your programs. Is there a way to break it down? You don't want to break it down too much, because then your program is just made up of, you know, 1-line code that is inside a function, and that's not good either. But if you have a bunch of code like this, which you know that you might potentially paste in multiple places, it will certainly help a lot also in debugging in the future if you ever have to modify small things. And it promoted this concept of modularity, which we'll see in a few lectures, which means that we're able to break down our program and test it separately. So notice at the beginning, if you remember, we tested this function separately from the rest of the code. And we made sure that the function was correct before we moved on to the more complicated part of the code. So I think that's probably all I have to say about this extract email function. Hopefully it was helpful. We're going to do this again tomorrow with a different program. This coding session will be available online for. We won't take it down, so it'll be on YouTube, and you'll be able to rewatch it again. So, all right, thank you for joining.